Hello everyone, and welcome to our 5.4 lesson on isosceles and equilateral triangles. And everyone has actually already heard those words before because in one of our first lessons we talked about classifying triangles, and we talked about what it means to be equilateral, where all the sides are the same, and what it means to be isosceles, where two of the sides are the same. So all this lesson is an extension of that, just to look at some of the properties, to look at some of the parts of an isosceles triangle, the parts of an equilateral triangle, and what we can do mathematically with these two types of triangles. And so we are going to take notes. The front side of this document are the notes, and then the back side of the document is your practice for homework. And so first let's look at isosceles triangles. So for an isosceles triangles, the two congruent sides are going to be referred to as the legs. These are the legs of that triangle. So those are the ones with the congruence marks, and that just tells you that BA is going to be congruent to BC. Those two legs are going to be congruent to each other. Those are the same length. And the angle included between those legs, which y'all now know means in between, that is going to be called the vertex angle. It kind of helps me remember it because it forms a V with the legs. So that is the vertex angle. In our picture, that will be angle 1. The side that is opposite that, so this one right here, that third side, we are going to call the base. Now in this picture, it is currently sitting on the bottom, but just because it's on the bottom in this picture does not mean it always has to be on the bottom. It could be on the top, on the side. It just happens to be on the bottom in this picture. So it is going to be that side opposite the vertex angle, and that is our base, and then our legs were in yellow. So I'm just getting this color coded. Our vertex angle I'm going to put in green. You can kind of see this in the key. And then the angles that sit on top of that base, any angle that touches the base, is going to be called the base angles. There's two of them. Those are the base angles. And angle 2 and angle 2 and angle 3 are those base angles. So the angles that sit on the base. And so now we're going to learn two theorems that relate those base angles and the legs of the triangles. So there is a theorem called the isosceles triangle theorem. Very appropriately named. It's about isosceles triangles, and it's a theorem that goes with them. So here's what it says. If two sides of a triangle are congruent, then the angles, or the base angles, opposite those sides are also congruent. So if you have that those two legs are congruent, those two congruent sides, then those base angles are going to be congruent as well. So I'm just following that color scheme. So if we know that the legs are congruent, in this shape in the picture it says AB is congruent to CB. If we know that those legs are congruent, then immediately we know that angle 2 is congruent to angle 3. So in our picture we would say angle 2 is congruent to angle 3. We knew that because in our picture BA was congruent to BC. So because we knew that those legs were congruent with those little congruence markings, we could immediately say that those angles have to be congruent as well. So that's our isosceles triangle theorem. We also have the converse of the isosceles triangle theorem. So remember that the isosceles triangle, the theorem just says, the conditional statement says if P then Q. And so the converse of that is just going to say if Q then P. So if Q then P. So it just goes backwards. So it's saying, hey, if you look at a picture, if you look at a triangle, and let me see, where's my blue color? And the two angles of the triangle are marked as congruent. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's isosceles, and those two sides must be the same as well. So what that means is that if we knew that angle 2 and angle 3 were congruent to each other, immediately we would know that those sides, BA and BC, would have to be congruent. So this just reverses it around. That's the converse. All right, so now we're going to do some examples. We are going to look at this crazy picture. Now this crazy picture has a huge triangle, ADF. It also has smaller triangles, ABC, BDF, BFC in the middle, and CFE on the side. And so we're going to look at it, and we're going to fill in some things. It says, if we know that angle ABC, so let's go find that. I'm going to do that in colors, actually, same colors we used before. If we know that angle ABC, this one right here, is congruent to angle ACB, then what can we conclude? Well, we just learned a theorem that's the converse theorem, said if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So the sides opposite those angles would be these. Angle B opens up to side AC. Angle C opens up to side AB. So what can we conclude? We can conclude that AB must be congruent to AC, and then thus that is an isosceles triangle. Why is that? That is because of the converse of isosceles triangle theorem. Okay. This one instead starts with, so this one started with angles and added the legs. This one is the reverse of that. It starts with the legs, and then we're going to add the angles. So it says, in our picture, if BD is the same as BF, then what can we conclude? We can then conclude that those base angles are going to be congruent. Angle, I'm going to name it with 3 letters just because I can't just call that angle. Is that supposed to be an E? I think that's supposed to be an E. Hold on one second, guys. Let me make that a little bit darker for us. Yeah, that's supposed to be an E. Okay, so let's check that. I'm not just going to call that angle D. I could, but because I'm going to use 3 letters on the other one, I'm a creature of habit, so I want to use 3 letters on this one. So when I go to name this angle, I'm going to name it angle BDE. Angle BDE is going to be forced to be congruent to angle BED. BED. That is just the normal, because I went from sides to angles. That is our normal isosceles triangle theorem. Isosceles triangle theorem. All right. So now we're going to actually start using some algebra and some numbers and actually just do a little bit of math on these triangles. So it says solve for the indicated values. So number one is an isosceles triangle. I know that because the legs are marked as congruent. And so those are my legs. And then here's my base. I kind of like to have it color-coded because it just helps me out in a second. And KLJ is currently marked as 68 degrees. It wants to know what is KJL. What is this one right here? So that is going to be the other base angle. So because the legs are marked as congruent, I can mark the base angles as congruent. That is what the isosceles triangle theorem tells me. So KJL is also going to be 68 degrees. I can fill in 68 degrees here as well. If I want to know what JKL is, which is the vertex angle, so vertex angle, this one was a base angle. Just make a note of that. If I want to know what the vertex angle is, I can do 180 minus 68, because I use those in both of the bottom corners, and that is going to give me 44 degrees left for this top angle. So I like to think about this like parents with a budget. If I give $68 to both of my kids and I have $180 in the budget that month, I'm only going to have 44 left for that parent angle, that vertex angle. Now this problem is a little bit different because I've turned it on you. I've kind of turned it sideways, and so when I'm looking at my legs in this problem, they are actually oriented a different way. And so I know that that 106 degree angle is my, that is going to be my parent angle is what I just kind of referred to it as a second ago. But that's between the legs, that's my vertex angle. And then here is my base, CE is the base. So here's the base angles that sit on that. And so since the legs are marked as congruent, I can go ahead and mark the, oh goodness, y'all, sorry. Since the legs are marked as congruent, like in this picture, I can go ahead and mark the base angles as congruent. So if we want to know what angle DCE is, that's this one, but it's going to be the same as this one. So an easy way to do that is to subtract out what the parent gets. We're starting with the parent this month for some reason. They're taking their money out first. They need it for something important, and that is 74 degrees. But that 74 degrees is the remainder of what is left for both kids. So what I'm going to do is I'm going to take that 74 and I'm going to split it in half. I'm going to divide it by 2. That leaves 37 degrees for each of these base angles. So this one would be 37. The other kid would get 37 as well. So both of those base angles would add up to 74. So this one was the reverse of what the last one asked me. The last one gave me a base angle and I had to find the vertex angle. And this one gave me the vertex angle and asked me to find a base angle. All right, now number 3 is different than what you've seen so far. Number 3 does not have any congruence marks on it, not a single one. And so at first I was hesitant because I was like, well, I can't solve this problem. But then I saw something interesting. This is 77 and this is 77, meaning that this is the base If both of those are 77, I can mark them as congruent, which means that the legs must be congruent. So this turns this into an isosceles triangle. So this is the converse of the isosceles triangle theorem, okay? And so what I'm going to do, I like to highlight everything beforehand. I added my congruence marks. We immediately know that YZ, that's this piece right here, YZ is also going to be 12 centimeters because the other leg is 12. It then wants me to find my vertex angle, angle XYZ, so starting here, going here, going here. It wants me to find this angle right here, XYZ. And so what I'm going to do is I'm going to do 180 minus the $77 that I spent on both of the kids, or the 77 degrees I spent on both base angles. And when you do that, let's see how much we have left for the vertex angle. That is 26 degrees. That makes sense in regards to my picture because that is an acute angle like I anticipated. Okay, so now we have another triangle that looks very similar to the one from before, except that I have the base angles marked as congruent. Beforehand, I just had two numbers and I had to mark them as congruent. This question comes loaded with the congruent symbols. And so there are my base angles. Here is my base. Y'all know I'm a creature of habit and I love to color code things. So this just really helps me see everything. And so that before I'm even going and looking what it's asking me for, I know what piece is what piece. So my vertex angle's in pink, my base angles are in green, my legs are in blue. Okay, so since those base angles are congruent, boom, I get to add congruence marks right here. This is an isosceles triangle because its base angles are congruent, the legs are congruent, and thus it is an isosceles triangle. So what does it want us to find? It wants us to find x. And this is a tricky, tricky, tricky problem, y'all, because it's got three different legs that all have an x in it. So here's what they're trying to do. On this problem, they are trying to confuse you. And by that, I mean what they're really trying to do is make sure that you understand the concept of what legs I can set equal and what legs I cannot set equal. And so the base is not necessarily the same length as the legs. Now it can be, in which case we could also call it an equilateral triangle, but the only ones that are marked congruent that have an X in them are these two. And so the only ones that I can work with as far as setting anything equal, the only ones I know for sure by definition of this isosceles triangle that are equal are these two. I actually have this 9x plus 2 on here as a distractor. However, it's on there so that we can see if we know what x is, we can go back and plug it in and see what that value is. So when I solve for x, I'm going to subtract 3x from both sides. I get negative 3x minus 12 equals 12. I add 12 to both sides. Negative 3x equals 24, so x is negative 8. So that's what I fill in for my value of x. Let's see if that makes sense. What did I miss, y'all? Hold on one second. That is a positive 3x. I knew that would be wrong. Hold on, let's pause. Teachable moment, guys. How did I know that that was wrong? Well, because when I went to plug in a negative 8 here, this gave me a negative 48. Minus 12 would be negative 60. We know that we cannot have a negative side length in a triangle, so I knew that I made a mistake. But instead of erasing it all, I just went back and tried to catch my mistake. I did good math here. The only thing I changed was this was supposed to be a positive 3x, which makes this a positive 8. So if I wanted to know what the legs were, let me fix this up a little bit. If I wanted to know what the legs were, I could plug in 8. That would be 6 times 8 is 48. Minus 12 is 36. This is just checking to see if I did good work. 3 times 8 is 24, plus 12 is, let me do this real quick, plus 12 is also going to be 36, so both of those legs are what I anticipated them to be. We could actually make a decision to see if this happens to be an equilateral triangle by plugging in 8 here. 9 times 8 is 72, plus 2 is 74. So because that's a 36, and a 74, this is only isosceles. This is not equilateral. All right. Let's see. This one, we've got our legs marked congruent. The isosceles, let's see. The legs are congruent. The isosceles triangle theorem tells me that if those legs are congruent, then boom, these base angles are congruent because there's my base. Those base angles are going to be congruent to each other. And then here is my vertex angle in pink. So I just like to color code it every time. That way, no matter how they turn the triangle, I've got all my pieces ready to go. So they do want to know what x is. That is not the other vertex angle. If it was, I would just fill in 54 and I would be done. But 54 actually goes right here. So that is not what x is. They're actually asking me for my vertex angle here. So I would do 180 minus the 54 I spent at both of the base angles. So when I do that, I get 180 minus 54 minus 54. That is a 72-degree angle. That is 72 degrees for my vertex angle. That's the one between the legs. All right, I'm just giving y'all every kind of possible combination of things here with isosceles triangles. Y'all are gonna have this down by the time we are done. So those are my legs. Those are marked as congruent. So since those are marked as congruent, boom, the isosceles triangle theorem tells me that my base angles are going to be congruent as well. And then here is my vertex angle. So we want to know what the value of x is. And so which ones have an x in them? Actually, the two base angles. And so I can take those two expressions and I can set them equal because both of them have, those are congruent angles. So I'm going to subtract and get these on the same side. And then so x is going to be a positive 20. Let's plug that in and just make sure that that makes sense. 3 times 20 is 60. So I know I did that. And then 4 times 20 is 80 minus 20 is 60. So I know I did it right because those are both 60. So question for you. Challenge question, we're doing this in class 2. If those are both 60, what does that leave for the vertex angle if I wanted to find what it was? Well, you could go 180 minus 60, which actually leaves you 60 degrees for this vertex angle. So because all of these are 60, that's just like a little preview for what's to come. This is actually also an equilateral triangle. An isosceles triangle is defined as having at least 2 sides congruent. So this is also going to be equilateral because we can add a third side because all of those are 60. So just a little fun fact there that you might not think is that fun, which is fine. All right, let's move on to the next one. So here we go. Isosceles, because the legs are congruent. Because the legs are congruent, then boom, isosceles triangle theorem tells me these base angles must also be congruent to each other. So if this is same as that, here is my vertex angle, and we want to solve for x. Several ways you can do this. You could go 180 minus 40 is 140. 140 divided by 2. So I'm going to do that real quick. 180 minus 40 is 140. We know that that's going to be divided by, let me write this out a little bit better. 140 over 2 is 70. So I can take now, each of those is going to be equal to 70. 70 and 70. So I can take 70 and set it equal to 2x, and then x is 35. So that's one way you could do it. You could also, I'm going to say or, you could also put a 2x here as well and go 2x plus 2x plus 40 equals 180, and then 4x equals 140, so x would be 35. So either way, you get x is 35. Way more than one way to do it, totally fine. So if x is 35, they want to know what is the measure of PRQ. PRQ is this one right here. We know that that is 70 degrees because 2 times 35 is 70, and I've already figured out that 70. Both base angles are 70, and the vertex angle is 40. All right, we're going to keep color coding. This color coding magic helps my brain, and I hope it's helping yours. Here we go. There are the legs. Here is the base. Base angles are going to be congruent to each other. Boom, boom. But this actually isn't asking me anything about angles. This is actually only asking me about legs and the base. And so again, this is just checking your understanding of what values you can actually set equal. So in an isosceles triangle, the legs are congruent. So I'm going to set 40 equal to 6x plus 4, because those are the only things that I actually know are 100% equal, congruent. And so x is 6. X is 6. We could check that by going right here. 6 times 6 is 36 plus 4 is in fact 40. So I know that I did good math there. It also wants to know what UW is. UW is that base. Now that we know that x is 6, this is going to be 5 times 6. So 5 times 6. 5 times 6 is 30. So you actually had to solve for x first on this one before you could find what UW was. Okay. All right, here we go. So these are overlapping isosceles triangles. You can see that because watch what happens. Here's one. Boom, boom, legs, which makes this base. Base angles are going to be congruent here. Here's my vertex angle. This isosceles triangle is overlapping this one with 2 legs, 2 markings on the legs, 2 markings on the legs. Here's my vertex angle on this one. And then here are my base angles. Here we go. And here we go. And then notice they have a 90 right here. They don't have that on there for funsies, so we're going to use that in a second. And so what we're going to do on this problem is figure out x first. I can't start on the triangle on the right because there's two variables in it. I need to have at least a number. I guess technically there's two unknowns on this side too, but because this is x, I also know that this is x. So those are the same variable. So I'm going to go 180 minus 51. 180 minus 51, just double checking my math here because my brain is, there we go, 129, that's what I thought. And then we're going to take that 129 and split it into 2. 129 divided by 2 is equal to 64.5. So if I know that this is 64.5 for x, this is 64.5 as well. We're going to use the fact that this is a right angle to do 90 minus, let's do that in a different color. So here we go, there's 90. So it's going to be 90 minus 64.5. 90 minus 64.5, or in other words, the complement of that is 25.5. So why does that help me? Because if this is 25.5, then this base angle also must be 25.5. So 25.5 is spent in both of those base angles. And so now if I want to find z up here is just going to be the parent angle is what I like to call it, but that's going to be the vertex angle. So to find z, I'm going to do 180 minus 25.5 minus 25.5. So we're just going to subtract out what I spent at both of those base angles. So definitely a challenging question here. Y'all are doing hard math, and that gives me 129 degrees for z. So a lot going on whenever we attach more than one triangle to itself. Those are overlapping. Okay. All right, for this next problem, again, we have two triangles going on. We have this one on the bottom and then that one on the top. Now, what's interesting about these, if you look, this kind of makes a star pattern. All four of those legs are congruent. All four of them. So watch this. Here's my base angles, boom, my base angles. And then my vertex angles, when I highlight those, are actually vertical. So the only number, I know I need to start with a number if I'm going to find an unknown variable. The only number that is even listed on this triangle is 140, and it's actually on the outside. It's not in one of my interior angles. So think about what we've learned in the past that might help us on this problem. 140 and this base angle make a linear pair. Linear pairs add up to 180. So if I do 180 minus 140, I get 40 here. That allows me to copy that into this base angle. I only could do that because this is isosceles because of those congruence markings. If I do 180 minus 40 minus 40, that gives me 100 degrees for that vertex angle. So if that vertex angle is 100 degrees, that's x. But we want to climb the ladder and get to y. So I'm going to copy it across to be 100. These are congruent isosceles triangles, so I can go ahead and copy the 40 here and here. If you didn't know that, you just go 180 minus 100 is 80, divided by 2 is 40, so both of those are 40. Again, we're going to use our linear pair to get outside, so if that's 180 minus 40 on the inside, that is going to give me 140 for y. So you could kind of just see these end up being congruent. We have two congruent isosceles triangles, so if this exterior angle is 140, it makes sense that that one would be 140 as well. All right, let's see. We've got our congruence marks, so there's my legs. I do this every time, y'all. It really, really, really does help. There's my base. There are my base angles. And so here's my vertex angle. And I'm going to stop there. So let's see what we've got. The 63 is my linear pair. There's my number. So I'm going to do 180 minus 63. And that's going to allow me to get into this triangle. So 180 minus 63. 180 minus 63 is 117. And I'm going to take 117 and divide that by 2. And I get 58.5. So this was 117. This is 58.5. Interestingly enough, y is marked congruent, so I immediately know y is 58.5. This is 58.5 because those are, hold on one second. Hold on, we can't do that yet. Okay, we can't do that yet because those are two different markings, and we did not know for sure that the one on the top is isosceles. So hold on one second, y'all. That is 117. Those are marked the same. Okay, so this is interesting. So because we know that this one is going to be the same as this one, if those are going to be congruent, that makes this an isosceles triangle as well. So these are all four actually going to be congruent. So that makes this 58.5, that makes this 58.5, and so this is actually also going to be 117, because again, those are congruent. So x is 117 degrees. So it'd be different if we had the markings the same on both of those at the top. We would have immediately been able to say it was isosceles, but you kind of had to pay attention to the fact that these were base angles that we knew were congruent because of isosceles, and then because these two were marked the same, and because these two were marked the same, then all four had to be marked the same, since these twins had to be the same as well. So these end up being congruent isosceles triangles. We knew that from the start here because they had all the leg markings. We did not know that over here, but we ended up being able to find out that it was true. All right, I love right isosceles triangles. My vertex angle is a right angle here. My legs are marked as congruent. My base is here, so my base angles are here. The legs are congruent, so the base angles are congruent. So I can go ahead and copy a 5x here. So 5x plus 5x plus 90 equals 180. I could also just go 180 minus 90, which is kind of what y'all are about to do. 10x equals 90, so x equals 9, which makes sense because that'd be a 45, 45, 90 triangle, and that does add up to 180. So they just wanted x here, so it's 9. So that is like if you zoom out, goodness, y'all, we just did a ton of questions. That is like every kind of isosceles triangle that will ever be thrown at you. Now you know how to do them all. So the only other thing we have left is equilateral and equiangular triangles, which I know that y'all know the definition of. Just wanted to make sure that we have it formally written out. For equilateral triangles, a triangle is equilateral if and only if it is equiangular, meaning that all the angles are going to be equal to each other. So angle A, angle B, and angle C will all be congruent. That is true because all the sides are congruent, so the side that they open up to is going to be the same. And so 180 divided by 3 gives me 60 degrees for each of those angles. This would be 60, this would be 60, and then this would be 60. That is always true. So we know that if it says, here's our theorem, if all the angles are congruent, then boom, all of the sides are congruent. So AB is going to be congruent to BC, which is going to be congruent to AC. And then if all the sides are the same, then boom, we know that all the angles are going to be the same. That just says the converse, essentially. So if you see a picture and you only have the sides marked, all three sides marked the same, boom, add that all the angles are the same and add that they're 60. The converse of that says that if all of the angles are marked the same, boom, you know that it's an equilateral triangle and you can add all the legs. So it says solve for the indicated values. Now we only have 3 of these total. So it tells me given PQR is equilateral. So even though they don't have the markings on there, I could add them. I think they just didn't have room with all this algebra stuff on it. And so the difference between this problem and the base problem that we did before is all 3 of these are the same length. So when I'm looking to solve for x, I just go find the ones, I'm looking to solve for y. All of these have a y in it. So earlier I had to set the 2 legs congruent. I can set any of these congruent because all 3 of these are the same length. So I'm just going to pick 2 of them, 14y minus 59, and I'm going to pick 9y plus 1. So when I solve for this, I get 5y equals 60, so y is 12. If we had done that with any of the other sides, we still would have gotten y is 12. Like if I had picked 9y plus 1 and 11y minus 23, I'd get 2y equals 24. We still would have gotten y is 12. So I just wanted to show you that that holds true. No combination would give you a different y value. And then it wants to know what x is. Well, where is x? X is pointing to an expression for an angle. So I get to add that all of these angles are 60. And so I can just take 7x minus 3 and set it equal to 60. I get 7x equals 63. So x is going to have to be 9. The only other thing they want you to do is actually go back and plug in y and find out what PQ is. So PQ is going to be 14 times 12 minus 59. So 14 times 12, let me write this out somewhere. 14 times 12 minus 59 is going to be, oh goodness, sorry guys. 168 minus 59, which is 109. That is a length, not a degree. So since I'm filling in a side length, I'm just going to leave that as 109 and not put 109 degrees. All right, so what is the value of angle C? If this is 60 and this is 60, 180 minus 60 minus 60 gives me 60 degrees. So the reason that that's written first is if that's 60, then boom, this is an equilateral triangle. So now we want to know, well, what is BC, the length of BC? Well, it has to be 9 because all the other side length is 9. So all of them would be 9. Had they asked me what AC was, I would still put 9. Last problem. So we've got a equilateral triangle. I know it's equilateral because all 3 side lengths are marked congruent. Since all 3 side lengths are marked congruent, I know that all 3 angles are going to be congruent. On all 3 of them are going to be 60 degrees. So I'm just going to go ahead and fill that in before I even get to the questions. It makes it really easy because now that they ask what angle J is, boom, it's 60. And then they want to know, well, then what is JK? Not an angle, but a side. It is also going to be 24 because it's marked the same as this 24. So your homework is on the back. It's got isosceles triangles, it's got equilateral, it's got some overlapping. It is those 19 questions. And if you need help on it, flip it back over to